Myself, Dr.Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, in our lecture, I want to discuss a standard case, a special case to solve a linear differential equation of second order with constant coefficient. How we can say that this is a special case? Because in this case, the value of q, which is the function of x, which is present on the right hand side of the given differential equation. So main important is this: in q there are three functions involved. Last lectures we have already discussed when q have only one function, any one function, either exponential or trigonometry or algebraic. There are only three functions basically involved in particular integral. So in Q, there are single function, exponential function, trigonometrical function, and algebraic function. One by one, single functions occurs in our given differential equation. This is the first case. Now case second. Next case second, there are two functions involved simultaneously in our given differential equation. Both functions are in multiply, either exponential into trigonometry or trigonometry into algebraic or exponential into algebraic. But in third case, this is most and important case, because here three functions involved. All three functions, exponential function, trigonometrical function, and algebraic function. All functions, three functions involved in our question. So this type of problem is very important. All three functions are given in multiply. So how we can solve a particular integral in this case? So in this lecture, we will discuss this special case if there are three functions in Q. In case 8, we have already discussed case 7, but now I want to discuss case number 8. If Q is, what is Q here? Q is, there are three functions in this case. First is exponential function. Second is sin AX, sin BX. We are writing here B. Sin BX, sin BX, not AX. B is other number, A is other number, and into x to the power n. So in our question, there are three functions. All three functions are given in multiply. First function is algebraic function, second function is trigonometrical function, and third function is algebraic function. So this is the special case. Here all three functions which is given in case 1, case 2 and case this 3. So all functions are in given multiply. In case 8, we will discuss a special case to solve a linear differential equation of second order with constant coefficient in standard form. What is standard form of Q? Q is e to the power ax and sin ax, sin bx, and x to the power n. In Q, there are three functions. I have already told about there are three functions. All functions are in multiply. All functions are compulsory in this case. Then we discuss case 8. There must be three functions. All functions are in multiply. First function is exponential function in case 8, and second function is sin bx or cos bx. In both, maybe both, either this one or this one, sin bx or cos bx, where v is an algebraic function x to the power n, where a and b constant may be positive or negative. A constant occurs in exponential function, b constant occur in trigonometrical function, sin bx or cos bx, and n number occurs in algebraic function. But here n always be positive constant. In algebraic function, the power of variable always be positive. So we want to discuss about particular integral. If functions, there are three functions in Q, so how we can find the particular integral easily way. General differential equation of case 8. Which is the general differential equation of case 8? Given as follows. I am given here, this is equation 1, is known as a general equation of case 8. Case 8 means three functions involved in Q. So now equation is here d2y over dx2 second derivative multiply by 1 number this, and dy dx this is first derivative, here multiply by p1, next is y plus p2 multiply by p2, y is our function multiply by p2 is right hand side. This is q. In q there are three function, 1 function 2 function 3. First function exponential e to the power ax, second is sin bx trigonometrical function, third is algebraic function x to the power n. So this equation 1 is known as a general linear differential equation of second order with constant coefficient. Here p1 and p2 are number, are constant, and exponential function is first function. Second function is sin bx or cos bx, and third function is an algebraic function x to the power n. But here q equal to e to the power ax into sin bx and into x to the power n. This is value of q here. This is function 1, this is function 2, this is function 3. All functions are in multiply. Here a, b and n are numbers, are constant. So basically this is known as a general linear differential equation of second order with constant coefficient. In right hand side is q. But in case 8, there are three functions involved in q. All three functions are in multiply in q. And all three functions, one function is exponential, second is trigonometrical function, and third is algebraic function. Now in case 8, we will discuss about standard differential equation. This is the given differential equation 1 and second differential equation this 2. In first differential equation is trigonometrical function is sin bx. Other first and last function third are same. Second differential equation, general differential equation, there is cos bx. Other functions are same. So in general differential equation, there may be sin bx or cos bx. Only two functions of trigonometry is involved. Sin bx in this equation is sin bx. In this equation is cos bx. These only two functions involve of trigonometrical function, not other function. We are not considering here tan ax, tan bx, cot bx, sec bx, and cosec bx. We are not considering these functions. These functions are not allowed here. Cross. But these two functions are allowed here. Here A, B may be positive and negative. A is the number in exponential, B is the number in trigonometry, and N is number in algebraic function. So N is positive number. In case 8, we will discuss about the method which is applied in given standard equation. In this topic, we have already discussed if d square of sine ax is given, then we can write minus a square sine ax. This is proved. And sine ax cancel, means d square equal to minus a square. We can put this. This is the one rule. Next, in place of d square, putting minus a square. Next rule, what rule in 1? This is d and e to the power ax. E to the power ax into b. B is other function. There are two functions. What will be happen when two function is given? And we differentiate of these functions. One is exponential function, other is any function b. So here we see that exponential taking to left side, e to the power ax, and putting d equal to d plus a and b. We are putting this together. Okay. Similarly, if d square, here is d square e to the power ax into b. What will be happen? D square, here e to the power ax taking left side and putting d equal to d plus a ka whole square and into b. This formula we apply here. I am proving this formula in this case. We have already discussed this formula. So now this formula is exponential function taking left side, putting d equal to d plus a ka whole square into b. Similarly, here is d cube e to the power ax into b. So exponential function taking left side, putting d equal to d plus a whole to the power cube, because here is d cube, putting d equal to d plus a ka whole cube into b. So similarly, these results are already proved. In this case, exponential function taking to the left side of pi and putting d equal to d plus a in denominator of pi, not in numerator. After applying this method, we can apply last case 4 and 5 here, which we have already discussed in last lectures. Problem 1 based on case 8. So here I want to solve one problem that is depend on 100% case 8. Case 8. Problem is this: solve d2y over dx2 minus 4 dy dx plus 4y equal to, here is sine 2x. Here is sine 2x. So this is q. Q equal to here 8x square e to the power 2x into sine 2x. This is q. That is in right hand side. Right hand side is the function of x. This is function is q. In this q there are three functions. One is algebraic, other is exponential, and last is trigonometrical function. So how we can find complete solution of this problem? So basically, in left hand side there is number 4, 4 and into 1. Second derivative multiply by 1. First derivative multiply by minus 4 and function y multiply by plus 4. So this is all constant multiply here. So this differential equation is known as a linear differential equation of second order with constant coefficient. How we can say here special case is apply here? In case number 8. Case number 8 is a special case. How we can say? So here in Q there are three functions. All functions are in multiply. Number 1 algebraic, number 2 trigonometry, number 3 exponential function. So solution. we start the solution of this problem. d2 by dx2 minus 4d by dx plus 4y. I am writing same question here. Equal to 8 x square e to the power 2x into sine 2x. This is equation 1. This is given in our question paper, and we write first solution. Solution means start, and I am writing question first. So equation 1 can be written as this differential equation written as d form. D form means d over dx. I am writing capital D. d2 over dx2 writing d square. Okay. So in first term is that's a second time derivative. So d2 over dx2 is d square. I am writing here d square minus 4d. Here one time derivative here. So I am d over dx. I am writing d plus 4. Y is common in all terms. Y is here. Y is here. Y is here. So this y taking to the right hand side common. Never taking left side. If any student taking this y on left side common, then question wrong, because this is differentiable. Y is here differentiable. Here two time differentiable. Here one time differentiable. Here no differentiable. So if you taking this y to left side, that is out of differentiation. That goes to out of differentiation. So this is equation number 2. This is D form differential equation. Next, what is this is general form is this is FD into y is equal to Q. This is equation 3, where Q is this function, not x square. Here is sine 2x. Here is sine 2x, not x square, sine 2x. Solution of equation 2 in two part, because Q is given here. If Q is given, then we find two solutions. One solution is complementary function. Second solution is particular integral. So here Q in our question Q is given. So now here first we will find complementary function. After it we will find PI, particular integral. To find complementary function, taking Q 0. Right hand side must be 0. Then we can find particular integral. Then we can find complementary function. So we are taking right hand side 0. Q taking 0 here in equation 2. Then we get this equation is 4. D square minus 4D plus 4y equal to 0. In 4 equation, we see that right hand side is 0, because I am putting Q equal to 0. Where FD, what is FD is function of D. D square minus 4D plus 4. This is FD. Now in 4, equation 4, putting D equal to M, because we want to an algebraic equation. How we can find algebraic equation? So putting in D form equation in D form, and right hand side is 0. In that equation putting D equal to M and removing y from 4. Then we get an auxiliary equation of 4. So now m square minus 4m plus 4 equal to 0. This is equation 6. Equation 6 is an auxiliary form. An auxiliary form of 4. Equation 6 is an auxiliary form of equation 4. Now factorizing equation 4. Equation 6. Factorizing of equation 6. Finding value of m. So m square minus 4m plus 4 equal to 0. This is depend on given formula. A square minus 2ab plus b square. This is a minus b ka whole square. We can write according above identity. Then we get factorizing of 6. So this is m minus 2 ka whole square. After opening this equal to m square plus 4 minus 4m. Okay, this is same equation is this. So here m minus 2 ka whole square equal to 0. M minus 2 into m minus 2. Twice factor. Whole square means twice. A square, a into a. Similarly, m minus 2 into m minus 2 equal to 0. If m minus 2 equal to 0, then m is 2. Again, if m minus 2 equal to 0, then m is 2. So here we find roots of m of an auxiliary form. Here we get roots of an auxiliary form. We get roots of an auxiliary form 6 is m equal to 2, 2. Here roots of an auxiliary form are equal. So we apply here formula for equal roots. This is given formula for equal roots equation 8. So C1 plus C2x e to the power mx. M is the roots, value of an auxiliary form. So C1, M is here 2, 2. 2, 2 is M. So putting C1 plus C2x e to the power 2x. This is equation 8. This is complete complementary function of given differential equation 1. Here finding second part of solution, that is Pi. Second part. First part is complete, that is complementary function. Now finding second part. We use here formula for Pi, for particular integral. Which formula we use here? So that is basic formula, general formula. We apply here to find Pi. So Pi equal to 1 upon Fd into Q. Fd means function of t, which is given in our differential equation. So here is 1 upon Fd Q. Q is e to the power ax, sin bx, x to the power n. There are three functions. All functions are in multiply in Q. Q equal to e to the power ax, sin bx into x to the power n. Three functions are there. So here we have discussed last which formula apply here. Exponential function taking left side. This is right side. Now this taking left side. Then putting d equal to d plus a. D putting d plus a. Fd convert in Fd plus a. One function goes to left side. Exponential first. First is exponential function goes to left side of Pi in multiply, in numerator. Other two functions are same place, not changing. These two functions are on right hand side. Exponential function goes to left side. Then d convert in d plus a. So this is basic formula we using in this question. Now value of q from equation 3 and fd from 5 putting in equation 9, then we get this is 9 equation. In this 9 equation, putting value of fd and value of fd and q, then we get equation number 10. Particular integral is equal to, this is the value of fd, d square minus 4d plus 4, 8e to the power 2x into sine 2x. This is sine 2x. So now next, rule 1, we have discussed in case 8, if q is e to the power ax sine bx this, then e to the power ax taking to the left side of pi in numerator and sine bx x to the power n taking right side of pi in numerator and putting d equal to d plus a in denominator. In place of d equal to d plus a in denominator in place of d of pi, then we get. So now here pi is equal to, same formula we apply. So here 8e to the power 2x goes to left side. In our question is this 8e to the power 2x. This function goes to this side. And other function is sine 2x into x square. Sine 2x into x square. Here is sine 2x into x square. So now, this is sine 2x into x square. This is correct. This is correct. Sine 2x into x square. Other two function keeping right side. This function taking left side. A to the power 2x. Now putting d equal to d plus a. Here e to the power 2x taking left side. Here a is 2. A is here 2. So d plus a. Putting d equal to d plus a. Every place. So d plus a, here is d square. D plus a ka square means d plus 2 ka square. Minus 4 d plus 2 plus 4. Here is sine 2x into x square. Here is sine 2x into x square. This term. This is correct. So now opening this perfect square. D square plus 4 and plus 4d. Minus 4d minus 8 plus 4. So 4 is cancel this. 4d cancel this. So here is only remaining d square. Sine x square. But we know that 1 upon d means integration with respect to x. And here is constant function. Function is 1. So we integrate of fx. Here fx is 1. Constant function is there. So putting sine 2x. Now, here is sine 2x into x square. Sine 2x into x square. Same function, this goes to this. Same function, this. So here putting sine 2x. What is value of sine 2x? We have right here sine 2x. This equal to imaginary part of e to the power 2ix. Imaginary. IP means imaginary part of e to the power 2ix. Because the formula is cos 2x plus I sin 2x. So this is imaginary part. This is I. Imaginary part is this. So right here sin 2x equal to IP of. IP means imaginary part of e to the power 2ix. And cos 2x, this is RP of e to the power 2ix. In place of cos 2x, we can put this result. In place of sin 2x, we can put this result. Now from equation 12 we have, this is 2ix. Here a t to the power 2x, 1 upon d square. Here is sin 2x. In place of sin 2x, I am putting ip of e to the power 2ix. So ip of taking left side. So a t to the power 2x, this term writing here. So here ip of 1 upon d square e to the power 2ix x square. Again here exponential function comes. One function exponential taking left side. Here again exponential function. So e to the power 2ix taking again left side of pi in multiply in numerator. Putting d equal to d plus 2i. This function taking left side, putting d equal to, here is a. E to the power 2ix, this is e to the power ax. So a is again 2i. D equal to d plus a. So putting d plus 2i. D plus 2i. So d plus 2i, this goes to this side. So now here 8 e to the power 2x, ip of, this is taking left side. Now putting 1 upon d plus ia ka square into x square. Only single function is there, algebraic function. Two function we have break. First is exponential function e to the power ax taking left side, then putting d plus a. After is sin x there, sin ax. Sin ax I am writing in imaginary part, e to the power iax form. Then that algebraic function taking left side, then putting d plus ia. In place of d, putting d plus ia. Here is 2i. So now 8 e to the power 2x, ip of 1 upon, so here 2i, we are making here binomial. Here is 1 upon d plus 2i ka square. So 2i taking common. 2i taking common means square also common. So here we taking 2i ka square is common. So 2i is common, here is 1 d upon 2i ka whole square into x square. This is equation 14. Now again this at to the power 2x ip of e to the power 2ix 1 upon here 4i square. 4i square means minus 4. 2i ka whole square. This equal to 4i square. I square is minus 1. 4 into minus 1. So this minus 4. Because I square equal to minus 1. Now this power taking in numerator. Here is square that convert in inverse minus power. So I am writing 8 e to the power 2x ip of e to the power 2ix 1 upon minus 4. This is writing a numerator. So 1 plus d upon 2i whole to the power minus 2 x square. This is equation 15. Expanding by binomial to equation 15, apply following formula. How? What is the binomial formula? So I am writing here 1 plus x to the power n. 1 plus x to the power n means 1 plus nx, 1 plus nx plus by factorial 1 plus n into n minus 1 upon factorial 2x square plus n into n minus 1 n minus 2 upon factorial 3x cube. This goes to, if n is negative power, n is rational power, then this goes to infinity. Here is negative power. In our question, n is minus 2. So now putting n equal to minus 2. Then we get expansion of this. 8 e to the power 2x, ip of e to the power 2ix, 1 upon minus 4. Now, here I am using same formula, binomial formula. So 1 minus n is minus 2. 1 plus nx, this is x. 1 plus nx. So here is 1 plus x to the power n, and here is 1 plus d upon 2i to power whole minus 2. This is same. Compare here. Comparing, then n is minus 2. This is minus 2. N is minus 2 and x is d upon 2i. So both value putting in our formula, then we get this expansion. 1 minus n into x minus 2 into d upon 2i plus next n into n minus 1 upon factorial 2 minus 2 minus 2 minus 1 upon factorial 2 d upon 2i ka square plus next minus 2 minus 2 minus 1 n minus 1 n minus 2 upon factorial 3 d upon 2i ka whole cube. Similarly, we can expand this formula up to infinite. So this is function only single here, algebraic function. So now pi equal to 8 e to the power 2x, ip of e to the power 2ix, 1 upon 4i square. 4i square means minus 4. 1 minus 2 d upon 2i. I am writing here same. This minus 2 d upon 2i. Next, calculating this result. Minus 3 and minus 2 plus 6 upon 2. So here this is minus 2 and minus 3 plus 6 upon 2. D upon 2i ka square. And same result this. Next one is here minus 2 d upon 2i plus 6 upon 2 d square upon 4i square. D square upon 4i square minus 24. How we can get 24? Last 24 is this. Minus 2 minus 2 minus 1 minus 3. Minus 2 minus 1 4. 4 3 is 6. 4 3 is 12. 12 2 is 24. Minus 24. Upon factorial 3. Factorial 3 is 6. Factorial 3 is 6. D cube upon 8i cube. And this infinity. Here is algebraic function. Now here we see that if we multiply by x square, this x square multiply this bracket here. If this x square goes to this, then in equation 13, then x square will be differentiate. So now multiply by x square, particular integral a t to the power 2x ip of e to the power 2ix 1 upon 4i square. Multiply x square to 1, that is x square. And here is d. D means d over dx. D differentiate with respect to x. To the function. Function is x square. So 1 is x square, dx square, d square x square, d cube of x square. So we know that d of x square, this is 2x. D square of x square, this is 2. D cube of x square, this is 0. D4 of x square, that is also 0. So all terms are vanished. This term and this term. So here x square multiply by 1, x square, dx square, d square x square, d cube of x square. So this term is 0. All other terms are 0. Only 1, 2, 3. These terms are remaining. So pi is equal to a t to the power 2x, ip of e to the power 2ix, 1 upon minus 4. I square is minus 1. So minus 4 in x square minus, here dx square is 2x upon 2i. Why here 2i? Upon 2i plus 6 upon 2. D square x square is 2 upon here 4i square is minus 4. This term is cancelled. Only this pi here. So pi is equal to e to the power 2ix upon minus 4 in bracket x square minus 1, 2 is cancelled, minus 1, 2x upon I. Here is 2 cancel, this 2 and this 2 cancel, 2 3 is 6 and 2 2 is 4. So minus 3 by 2. Now pi equal to a t to the power 2x ip of 1 upon minus 4 x square. Here multiply this I. So multiply in numerator and denominator I, because this I is complex. So I multiply in numerator and denominator. So this is I square. This is I. So now multiply by I. This I square. This is not I. I square is this. So here is 2ix. This is minus 1. This sign is minus 1 sign. Okay. This minus 1. This minus. So this equal to minus sign taking this a t to the power 2x ip of this 1 upon 8 2x square, and this sign is minus sign. Okay, multiply है minus आ रहा है. Here is minus plus. So multiply by I square. 4i square here. And this I multiply by plus हो जाएगा. This is plus. Minus minus this plus, correct. This plus already. So this plus sign. 4ix minus 3. Now this minus taking in numerator. This 3 upon minus 2, we write minus 3 by 2. So we write minus. This minus taking first. So here 8 e to the power 2ix 1 upon 8 2x square plus 4ix 2ix 4ix. Taking LCM, 2 is LCM, 2x square 4ix minus 3. Here 2 is LCM. Okay. 2 4 is 8. So this result here. Now pi minus e to the power 2x ip of in last ip of e to the power 2ix. E to the power 2ix we have given here formula. This is equal to cos 2x plus I sin 2x. This formula. I am writing this formula here in place of this. So we write here ip of cos 2x plus I sin 2x. 1 upon 8 2x square 4ix minus 3. Now equating here only imaginary part. This is IP. IP means imaginary part. In this in this total term, we find out the imaginary term only. That term which is multiplied by I. We are taking those terms in which I is present. That is imaginary term, imaginary part. So after multiply this bracket to this bracket, we find only those terms in which I present. So here real part multiply to imaginary and imaginary part multiply to real. Then we get imaginary part. So here we see that cos 2x is real and 4ix is imaginary. So cos 2x multiply 4ix. So 4x into cos 2x. Only one imaginary part. I sin 2x is imaginary part. Multiply real part in next bracket. So 2x square is real part and minus 3 is imaginary part. So 2x square sin 2x minus 3 sin 2x. So minus e to the power 2x 1 by 8, 4x cos 2x plus sin 2x is common, 2x square minus 3 sin 2x. This is complete pi. This is complete pi of 1. Okay. Complete solution by y is equal to cf plus pi. This is the formula. Y is equal to cf plus pi, complementary function plus particular integral. So y is equal to, this is complementary function and this is particular integral. So this is the complete solution. This type, this bracket I am writing here. And here is in our question, 8 is also in multiply. 8 is multiply. So now writing here 8 into 8. Here also multiply by 8. So 8 is cancelled. And finally, there is no 8. 8 number is cancelled by given 8 in our question. So this is the complete pi. Now this solution we can find this pi, we can find other method. So now, okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.